The National Electrical Code does not allow exceptions to the 42-inch clearance requirement in front of electrical panels. However, the Occupational Safety and Health Administration has specific guidelines for restricted access areas. 29 CFR 1910.303 states that clearances may be reduced if access to live parts is effectively restricted. 29 CFR 1910.303 requires that restricted access areas be marked with warning signs and barriers. The measurement of 42 inches from the panel is to the closest grounded surface. This means that the distance should be measured from the front of the enclosure to the nearest metal surface, ground rod, or other conductive material. The distance measurement is not affected by whether the components are dead front. The 42-inch clearance is required regardless of the location of live parts. It is advisable to closely follow the OSHA guidelines. Firstly, mark the area as restricted. Place warning signs and barriers around the electrical enclosure to prevent unauthorized access. Secondly, provide proper lighting. Ensure that the restricted area is well lit to reduce the risk of tripping or other accidents. Thirdly, install warning stickers. Apply stickers to the equipment warning of the electrical hazard and the need for restricted access. Fourthly, train employees. Inform employees about the restricted area and the safety precautions required. Fifthly, consider additional safety measures. If possible, implement additional safety measures such as remote monitoring or automatic shutdown devices to minimize the risk in case of an electrical accident. Adhering to these guidelines can mitigate the risk associated with reduced clearances while maintaining compliance with safety regulations. Electrical safety is paramount, and understanding the nuances of clearance requirements, especially in confined industrial settings, is critical. The National Electrical Code, or NEC, serves as the cornerstone for electrical installations, setting forth the standards designed to protect individuals and property from electrical hazards. One of the key provisions within the NEC addresses the clearance space required in front of electrical equipment, such as panels and enclosures, mandating a minimum of 42 inches to ensure safe operation, maintenance, and emergency access. This clearance zone is not merely a suggestion but a code requirement intended to provide electricians and other qualified personnel with adequate room to perform their tasks safely and efficiently. However, the reality of industrial environments often presents challenges in adhering strictly to these clearance requirements. Confined spaces, existing infrastructure, and operational constraints can make it difficult, if not impossible, to maintain the prescribed 42-inch clearance in all situations. Recognizing these challenges, regulatory bodies like the Occupational Safety and Health Administration, or OSHA, offer alternative guidelines that allow for some flexibility under specific conditions. While the NEC maintains its strict stance on clearance distances, OSHA acknowledges that in certain restricted access areas, clearances may be reduced if access to live parts is effectively controlled. This provision recognizes that in industrial settings, access to electrical equipment can be limited to authorized personnel who have received proper training and are aware of the potential hazards. To ensure the safety of personnel working in these restricted areas, OSHA mandates the implementation of specific safety measures, including warning signs, barriers, and proper lighting. These measures serve to alert individuals to the presence of electrical hazards and to prevent unauthorized access to live parts. In addition to these physical safeguards, training and awareness programs are essential to ensure that employees understand the risks associated with working in proximity to electrical equipment and are equipped to take appropriate precautions. When evaluating the feasibility of reducing clearances in a restricted access area, it is important to consider several factors. Firstly, the level of access control must be carefully assessed. Can access to the area be effectively restricted to authorized personnel only? Are there physical barriers in place to prevent unauthorized entry? Are warning signs prominently displayed to alert individuals to the presence of electrical hazards? Secondly, the potential hazards associated with the electrical equipment must be evaluated. What is the voltage level of the equipment? Are there exposed live parts that could pose a shock hazard? What is the likelihood of an electrical arc flash event? Thirdly, the tasks that will be performed in the area must be considered. Will electricians need to perform regular maintenance or repairs on the equipment? Will other personnel need to access the area for operational purposes? The answers to these questions will help determine the level of risk associated with reducing clearances and the appropriate safety measures that must be implemented. The measurement of the 42-inch clearance is a critical aspect of ensuring electrical safety. The NEC specifies that this distance is to be measured from the front of the electrical equipment to the nearest grounded surface or obstruction. This means that the measurement should be taken from the outermost point of the enclosure or panel to any adjacent wall, structure, or grounded object. The presence of dead front components, which are designed to prevent accidental contact with live parts, does not alter the clearance requirements. Even if all of the components within an electrical enclosure are dead front, the 42-inch clearance is still required to provide adequate working space for electricians and other qualified personnel. In situations where it is not possible to maintain the full 42-inch clearance, it is essential to consult with a qualified electrical engineer or safety professional to develop a comprehensive safety plan. This plan should address the specific hazards associated with the reduced clearance and outline the measures that will be taken to mitigate those risks. The plan should also be documented and readily available to all personnel who may need to access the area. In addition to the measures already discussed, there are several other safety precautions that can be implemented to further reduce the risk of electrical accidents in restricted access areas. These include the use of insulated tools and equipment, the implementation of lockout-tagout procedures, and the provision of personal protective equipment, or PPE, such as arc flash suits and gloves. Insulated tools and equipment are designed to protect electricians from electrical shock by providing a non-conductive barrier between the user and live parts. Lockout-tagout procedures are used to de-energize electrical equipment before any maintenance or repair work is performed. This prevents accidental energization of the equipment while work is in progress. PPE provides an additional layer of protection against electrical hazards such as arc flash, which can cause severe burns and other injuries. In conclusion, maintaining adequate clearance in front of electrical equipment is essential for ensuring electrical safety. While the NEC mandates a minimum of 42 inches of clearance, OSHA provides some flexibility in restricted access areas, provided that specific safety measures are implemented. When reducing clearances, it is important to carefully assess the hazards, implement appropriate safeguards, and consult with qualified professionals to develop a comprehensive safety plan. By taking these steps, it is possible to mitigate the risks associated with reduced clearances and maintain a safe working environment. The considerations around variable frequency drives, or VFDs, adds another layer of complexity to the discussion of electrical safety and clearance requirements. VFD are electronic devices used to control the speed of electric motors by varying the frequency and voltage supplied to the motor. They are commonly used in industrial applications to optimize energy consumption and improve process control. However, VFD also introduce potential electrical hazards that must be carefully addressed. One of the primary concerns with VFD is the presence of harmonic currents. Harmonic currents are non-sinusoidal currents that can distort the voltage waveform and cause overheating of electrical equipment. These currents can also interfere with the operation of other electronic devices and lead to equipment malfunction. To mitigate the effects of harmonic currents, VFD are often equipped with harmonic filters. These filters are designed to reduce the amplitude of the harmonic currents and improve the quality of the power supplied to the motor. Another concern with VFD is the potential for voltage transients. Voltage transients are short-duration voltage spikes that can damage sensitive electronic equipment. These transients can be caused by switching operations, lightning strikes, or other electrical disturbances. To protect against voltage transients, VFD are often equipped with surge suppressors. These suppressors are designed to clamp the voltage at a safe level and prevent damage to the VFD and other connected equipment. In addition to these electrical hazards, VFD can also generate heat. The electronic components within a VFD produce heat as they operate, and this heat must be dissipated to prevent overheating and equipment failure. VFD are typically mounted in enclosures to protect them from the environment and to provide a means of cooling. The enclosures may be equipped with fans or air conditioners to remove heat from the enclosure. When installing VFD enclosures, it is important to consider the clearance requirements specified by the manufacturer. These requirements may be more stringent than the general clearance requirements specified by the NEC. The manufacturer's instructions should be carefully followed to ensure that the VFD is properly installed and can operate safely and reliably. In addition to the manufacturer's instructions, it is also important to consider the ambient temperature in the area where the VFD is installed. VFD are typically rated for operation at a specific ambient temperature, and exceeding this temperature can reduce the lifespan of the VFD. If the ambient temperature is too high, it may be necessary to provide additional cooling to the VFD enclosure. The use of fusible disconnects in conjunction with VFD is another important safety consideration. Fusible disconnects are used to provide a means of disconnecting the VFD from the power supply in the event of a fault or overload. These disconnects are equipped with fuses that will blow and interrupt the circuit if the current exceeds a predetermined level. Fusible disconnects are typically installed upstream of the VFD to protect the VFD and other connected equipment from damage. When selecting a fusible disconnect for use with the VFD, it is important to choose a disconnect that is properly rated for the voltage and current requirements of the VFD. The disconnect should also be selected based on the type of protection required. Some disconnects provide only overload protection, while others provide both overload and short circuit protection. The selection of the appropriate disconnect will depend on the specific application and the level of protection required. The use of warning stickers and labels is an essential component of any electrical safety program. Warning stickers and labels are used to alert personnel to the presence of electrical hazards and to provide information about the safe operation and maintenance of electrical equipment. These stickers and labels should be prominently displayed on electrical enclosures, panels, and other equipment to ensure that they are easily visible to all personnel. The content of the warning stickers and labels should be clear, concise, and easy to understand. The stickers and labels should use standard symbols and terminology to convey the information effectively. The stickers and labels should also be durable and resistant to fading or damage from the environment. The use of color coding can also be an effective way to enhance the visibility of warning stickers and labels. For example, red is often used to indicate danger, while yellow is used to indicate caution. The color coding should be consistent throughout the facility to avoid confusion. In addition to the general warning stickers and labels, it may be necessary to provide specific instructions for operating or maintaining certain pieces of equipment. These instructions should be clearly written and should include step-by-step procedures for performing the task safely. The instructions should also include information about any potential hazards that may be encountered during the task. The training of employees is a critical aspect of ensuring electrical safety. Employees should be trained on the hazards associated with working with electrical equipment and on the safe work practices that must be followed to prevent accidents. The training should be tailored to the specific tasks that the employees will be performing and should include hands-on instruction and demonstrations. The training should also be updated regularly to reflect changes in technology, regulations, and best practices. The training should cover topics such as electrical safety fundamentals, lockout-tagout procedures, the use of PPE, and the proper use of electrical tools and equipment. The training should also emphasize the importance of following safety rules and procedures and of reporting any unsafe conditions or hazards. In addition to the formal training, employees should also receive ongoing coaching and mentoring from experienced personnel. This coaching and mentoring can help to reinforce the training and to provide employees with practical guidance on how to apply the safety principles in their daily work. The implementation of a comprehensive electrical safety program is essential for protecting employees from electrical hazards. This program should include written policies and procedures, regular safety audits, and ongoing training and education. The program should also be supported by management and should be actively promoted throughout the organization. The success of an electrical safety program depends on the commitment of all employees to following safety rules and procedures. Employees must be empowered to identify and report unsafe conditions and to take corrective action to prevent accidents. By creating a culture of safety, organizations can significantly reduce the risk of electrical injuries and fatalities.